Hi, in this video we're going to look at answering question 5 of the Core 2 Practice Paper 1. I've made these papers for AQA, but it's suitable for the exam boards, and you can find the link to the paper below if you've managed to stumble across the video without doing the questions. So in this particular question, it's asking us all about the equation of the line C, which is this curved line through here, and there's some parts drawn on here that we're going to end up working out. First of all, it wants the x coordinate of the point B here. Later on, we're going to work out the coordinates of the point A up here, which it says is a stationary point. And finally, in part C, it's asking us to work out the shaded area of this between the curve and the x-axis. Okay, let's make a start on part A then. Part A, calculate the x-coordinate of B. Well, the x-coordinate is when y equals 0. Remember that the x-axis is also called y equals 0. That's quite often a good starting place. If you get into the habit of calling the x-axis y equals 0, it'll help quite a lot. So let's have a look then. So we've got 3x to the power of a half minus x to the power 3 over 2, and I want this to be equal to 0. Right, well, this isn't very nice. It doesn't look particularly nice at all, and we can rearrange this in different ways if you prefer. It's still not going to look very nice. So we've got 3 root x minus root x cubed. We'll do it like that. Still not looking particularly good. How can we get rid of these powers of a half or the roots would be the question I'd be asking myself. Well, an easy way to do that is to square everything. So let's first of all square this first term here, or this first term, and that's going to get us 9x. Don't forget when you're squaring things to square everything on that term. So I've got to remember to square the 3 as well as just the root x. That's an easy mistake to make at that point. And finally we'll square this part here, which is just now going to be minus x cubed equal to 0. And you might be thinking, well, I still don't really know what I can do here. Well, let's just keep going through the process of the things that you will have done all the way through GCSE. At this point, can we factorise it? Well, we can take a factor of x out. So let's take a factor of x out and see what we've got left. 9 minus x squared equals 0. Okay, so we can now safely say that one of my solutions is when x equals 0. Which actually, looking at my picture, we can see. So this is satisfying that at least we're on the right track. Let's deal with this bracket now. 9 minus x squared. I'm hoping that you've noticed that this is a difference of 2 squares. So this will factorise to be 3 minus x and 3 plus x, giving me 2 more possible solutions. We could also say that x can be minus 3 and x can be 3. However, notice in the question up here, it says x has to be greater than or equal to 0 for this function here to work. Okay, so that means that this one here can't be the case. And we can say because x has to be greater than or equal to 0. So the only solution left is this one, x is 3. So the coordinate, the x-coordinate of B must be 3. Okay, shall we carry on now and look at part B? Part B says find the coordinates of A. So at this point we're remembering that this is a stationary point. Okay, and a stationary point means that we're going to have to do some work with the gradient. We know the gradient 0 at a stationary point. So what we need is the gradient function. So let's just write this out, minus x to the 3 over 2. What we're interested in is the gradient function dy by dx. So let's go through differentiating this. This is a typical core 2 sort of differentiation where you've got fractional powers. Everything else is going to stay the same now. I'm not going to get us to do anything different to what we were doing before. So let's have a think about this. We need to multiply by the power and reduce the power by 1. So I've got 3 over 2 x to the minus a half for the first term. Second term, multiply by the power, reduce the power by 1. So 3 over 2 now becomes a half. Now, again, at this point, I want to know, so stationary is when dy by dx equals 0. So let's see, I've now got this situation where we've got 3x to the minus a half minus 3 over 2x to the half is equal to 0. Not particularly nice looking, but is there something that we can do here? Oops, I've missed a little bit out. That's over 2. Well, first of all, notice that we've got over 2 here. So why don't we multiply everything by 2 first? At least that solves a few of our worries. So we've now got 3x to the minus a half minus 3x to the half equals 0. So that's a start. Okay, what should we do next? Well, again, why don't we do the same thing that we did in part A and square everything? That might just tidy it up a little bit. So now we've got 9x to the minus 1 minus 9x equals 0. So it's starting to look, well, a tiny bit better. At least I haven't got any fractional powers anymore. Let's make this look slightly different. Let's go with 9 over x minus 9x equals 0. Let's bring my 9x across. So I've got 9 over x equals 9x. Multiply both sides by x. And I'm just going to move now up here so we can see. We've now got 9 equals 9x squared. Divide both sides by 9. 1 equals x squared. So x equals 1. Okay, I've worked out what x is. Is that what the question is asking me? I feel like I've done a lot of maths, but I haven't yet answered the question. It says find the coordinates of A. I've only found the x coordinate. So if I substitute that in, sub into the equation, I'm going to get 3 minus 1, which is going to give me 2. So then y equals 2. So the coordinates I'm going to get are 1, 2. That is what A is. So A is 1, 2. Okay, good. That's quite tricky. I think the fractional powers there are not particularly nice. I think there's lots of things where you could have gone wrong, but we've got some nice numbers at the end. Okay, let's have a look for part C then. Part C asks us to find the area of the finite region enclosed by C and the x-axis. Okay, so we're finding the area between a curve and the x-axis. That's an integration question. So we're doing a bit of everything on this one. So what we need to do now is integrate between 0 and, well, b, which we know is 3. So integrating between 0 and 3. This function here, 3x to the half minus x to the 3 over 2 with respect to x. Big square brackets, and remember what we're going to be doing here is increasing the power by 1 and dividing by my new power. Okay, so increasing power by 1 divided by new power is going to give me, well, let's deal with the x part first. X, if I increase a half by 1, I get 3 over 2. So that's going to become 3 over 2. And dividing by 3 over 2 is the same as multiplying by 2/3. So I've now got 2 times 3 over 3, which is just 2. Okay, so I've done that in one go. You might set it out a little bit differently, but you will still get the end result here. Let's do the next bit. So we're increasing the power by 1, dividing by the new power. I like to do my powers first. So increase the power by 1, dividing by this new power, is the same as multiplying by, not 5 over 2, but 2 over 5. So let's put that bit in. So now I've got 2 over 5 here, between the limits of 0 and 3. So we're going to substitute our values in. We're going to get 2 lots of 3 to the power 3 over 2 minus 2/5 of 3 to the 5 over 2 minus, now if I substitute 0 in, I'm going to get nothing in this first bracket here, and I'm going to get nothing there, so minus 0 at the end. Okay, I can do this next bit on my calculator. I'm not expected to do it any other way, and so if I type the numbers in, I'm going to get 4.16 to 3 significant figures. Okay, so when you're taking revision card notes at the end, a couple of things that I've kind of highlighted in this video. I think where the curve crosses the x-axis is when y equals 0 is a really important thing. I think dealing with fractional powers by squaring, or it could be cubing or whatever, is going to be a good thing to do. Checking your solutions for validity. We've gone through that in terms of the brackets, the things that we could have had. Stationary points is differentiating, and areas to be found between curves and axes is integrating. Okay, hopefully you've got some correct answers here. If you did, well done. Have a look at the other videos for the rest of the questions and solutions. Thanks, bye.